Hello, good morning. I'm here again, Teacher Jeffrey. So we will discuss about entropy, free energy, and equilibrium. This will be the module 9. Thermodynamics. Thermodynamics is defined as the scientific study of the interconversion of heat and other kinds of energy, such as work. Thermochemistry, on the other hand, is the study of energy and heat associated with chemical reactions and or physical transformation. The difference between system and surroundings. System is the specific part of the universe that is involved in the chemical process, while surroundings are everything else that is not part of the system. There are three types of the system. We have open system, closed system, and isolated system. Open system, it is the type that can transfer both mass and energy with its surrounding. This is the example is the active volcano. Di ba yung bundok, meron siyang lava. So, meron siyang heat. So, pag hinawakan mo yung pinaka-mountain, so mainit siya. So, yung surroundings niya ay merong heat na kasama. Kaya nilagay ko dito, it can distribute heat around its surroundings as well as its mass. Next is closed system. This type can transfer energy but not mass to its surrounding. Next is isolated system. The type that cannot transfer both mass and energy. State function are properties that are determined by the values of all relevant microscopic properties of the state of a system regardless of how the condition was achieved. State function include the energy, pressure, volume, and temperature. Energy defined as the ability to do work. While pressure, it is a force exerted by the substance per unit area on another substance. Volume is the quantity of space occupied by matter. Temperature is the hotness or coldness of an object. Next is the laws of thermodynamics. The first law of thermodynamics, the law of conservation of energy. It states that energy can neither be created or destroyed. It can only be transferred or changed from one form to another. The example of this is the potential energy from the diesel. So, yung sasakyan, kapag siya ay merong gasolina, so it will transform into energy such as mechanical, electrical, kinetic energy, through engine combustion para makatakbo yung sasakyan. Okay? So, nag-start lang siya sa diesel, tapos na-convert siya as energy. Okay? This law simply means that even if a system may gain or loses energy from its surroundings, its total energy will still remain constant. That's this equation. So, E, this is the change in energy. Then Q is the heat, then the W, that is the work. So in the equation, represent all the internal energy, which is the sum of the potential and kinetic energy in the system, while Q represent the heat flow. The W represent works done by the system. So this is our formula. So W, work, is equivalent to negative P times the V. Okay? So, now we have here the given example. Given that Q heat is equivalent to negative 500 joule, the work will be 1000 joule. So, our formula is energy is equivalent to Q and the W is equivalent to negative 500 joule plus 1000 joule. So, negative 500 joule plus 1000 joule will be the answer is 500 joule. So this is our energy. Got it? So E is equivalent to heat plus work. So E is equivalent to negative 500 joule. That is our heat. This is the given. Then 1000 joule. There you go, the work. So negative 500 joule plus 1000 joule is equivalent to positive 500 joule. Okay? The second law of thermodynamics. It states that the entropy of the entire universe in an isolated system will never decrease. It suggests that entropy itself is symmetrical with time in an isolated system. It can also be stated that all spontaneous processes lead to an increase on entropy of the universe. Okay, this is our formula. Universe is equivalent to system plus surrounding less than 0. Spontaneous process is a process capable of proceeding in a given direction without the help of outside energy. Simply means a natural occurring process which does not require any kind of energy to do its work. Entropy, as is the symbol, it is a state function like volume, temperature, pressure, and energy. Unlike them, entropy cannot easily visualize. It is defined as the measurement of disorder or randomness within the system. High entropy means high disorder and low energy. However, in chemistry, we are only interested in change in enthalpy or H and not enthalpy directly. So this will be our formula. H is equivalent to H, the final, minus H, the initial, or H is equivalent to H, the products, minus H, the reactant. So the example is in the reaction 2H2 plus 0,2 will be 2H20. So H values for 2H2 is negative 50, while 0,2 equivalent to negative 12. Then 2H20 is equivalent to negative 223. So, gagawin natin. So, this is the product. So, H is equivalent to negative 50, open close parenthesis, plus, then the reactants is equivalent to negative 12, then the product is 223. So if we combine here, negative, then negative, our answer will be negative. So 50 plus 12 is 62. So negative 62. Then this will be the product. Negative 223 plus negative 62. So minus negative 223 plus negative sorry. This will be negative 62. So if both numbers are negative, if our subtraction is also negative, so the answer will be positive. So 223 plus negative 62 plus 62, the answer will be negative 161. Okay, so this one is the negative 50, the 2H2. The 0,2 is the negative 12. Then our product is negative 223. So the answer for this one is negative 62. We combine negative 50 plus negative 12. The answer is 62. Then we will add the negative 223 into positive 62. So the answer will be negative 161. Okay? Gibbs free energy, developed by an American scientist, Willard Gibbs, defined as the thermodynamics potential that can be used to calculate the maximum of reversal work that may be performed by a thermodynamic system at a constant temperature and pressure. Free energy change, the G symbol, is the difference between the product and the reactants. So G is equivalent to H minus T S. So if G is negative, it is a spontaneous reaction. If positive, non-spontaneous, and if it is equals to 0, it is the same of equilibrium. Chemical equilibrium, this concept was developed after a French chemist, Claude-Louis Berthollet, found that some chemical reactions are reversible. The third law of thermodynamics, developed by the German chemist Walter Nernst during the years 1906 to 1912. The third law of thermodynamics is often referred to as Nernst's theorem or Nernst's postulate. It states that entropy of a system approaches a constant value as the temperature approaches 0. So, thank you very much.